Enjoy the lesson and pay attention. I'll be keeping an eye on you.
Hello everyone and welcome to a new lesson on TIBCO BusinessWorks. In our last two lessons, we explored a fundamental topic, integration management based on file exchange. We saw how to retrieve and process files using activities like read file and file polar, how to write and move the files, and how to extract and integrate data for processing using data formats. Now, let's be honest, our main process has become a bit chaotic. It's time to bring some order to it. In this lesson, we'll focus on organizing our code to make it more manageable and more scalable. Stick with us until the end, because I'll also show you how to list files and directories in a super efficient way. To best organize your code, the key is to think of your processes across three distinct logical levels: main, operation, and integration. At the main level, you'll find your component processes. These are directly responsible for kicking off the execution flow. They're the true entry points of your system. Next up is the operation level. For each component process, you'll create a sub-process here. This is the heart of your business logic. It's where you orchestrate all the processing steps your flow needs to execute. Finally, at the integration level, you'll have the actual tasks your flow must perform. These processes are called by one or more processes from the operation level. This approach offers huge advantages. Imagine a new flow, for instance. It'll have its own dedicated main and operation processes, but it can call an integration process that's already been developed for another flow. This means pure code reuse. And there's more. If you need to add a new task to an existing flow in the future, you just create the relevant integration and call it within the operation level. The result: scalable and easily maintainable code. We're going to reorganize the activities in our main process by splitting up the tasks. Data parsing will become a separate task. We'll directly input the birth date calculation into the existing render data process, removing the need for an intermediate mapping. Then we'll generalize the file writing and moving operations, and finally we'll improve error handling. To do all this, we'll define four packages, one for the main level, one for operation, and two for integration. The main package is already there with the personal data component, so we'll create the operation package. And for the integration level, the data format and file packages. Let's jump straight into the integration processes. First, for the render data process, we already created it, so we just need to move it into the data format package. The TIBCO Studio will automatically update the references for us. In the same package, we'll create the parseperson subprocess. To quickly set up logging, you can copy and paste an existing process and rename it however. A little programmer tip: even though copy-pasting is convenient, my suggestion is to regenerate the process from scratch and only copy-paste the XSLTs when time allows. We'll do it the quick way for this lesson. Inside parsepersons, we'll insert the parse data activity instead of the render activity, and make sure to reference it to the correct data format. Parse data will need to receive a simple string as input, and its output will be an XML document containing the person's demographic data. The start and end elements of the process will need to be referenced to the corresponding elements we're about to create in a schema. One detail to note: the output of the parse data activity will generate a repeating element that we don't currently have for person. No problem at all. Let's create it in the schema, just like we did for person's age. So reference start and end with those elements. We'll input the starting string into the parse data activity, and then output the XML document of people. Quick break. How's it going so far? If you're enjoying this, don't forget to like and subscribe. Let's move on to writing the file. For this, we'll need the file name as input, and initially the header followed by the body to be written. So, we'll create a write file input element necessary for the process, with fields for the file name, the header to write, and the body to write. To speed things up, we'll copy and paste an existing process that uses a render activity. The input for this new process will be the element we just created. Now, let's copy the write activities from our main process. We'll delete the render data activity and insert the right activities in its place. At this point, we could leave the input unchanged. However, by passing this information as input, we make the process reusable for any other flow that needs to perform the exact same task. So, for the input to the right activities, we'll insert the file name, the headers, and the body to be written. By doing this, we're generalizing this process for any future flow that might need to accomplish the same task. A quick note, if you check the process properties, you might notice that the resource needed for the render data activity is still referenced. We can safely remove this. This just reminds us that every copy-paste, if not done carefully, can dirty our process. Ops forgot to rename. And finally, to wrap up the integration level, we have the move file process. For the same reusability reasons we discussed with write file, we'll create an XSD element that takes from file name and to file name as input. We'll then reference this input to our process. Inside, we'll insert the rename file activity, passing it the two file names as input. With these steps, our integration level is now complete. Let's move on to the operation level. The operation level is unique for each execution flow, so we'll generate person operation. This will receive for inputs from file polar, the file name only and file name include in path, his location, and the his content. The path information will be useful for moving the file later. Let's define these inputs in a schema for clear referencing. And reference it on operation start. Person operation will then sequentially invoke the integration processes we just created. First, it will parse the content file. After that, it will render the data. For the input here, we'll insert the XSLT from the mapper, sampling only the name it needs to iterate on. We'll copy and paste the variable that determines the name of the output data. It's interesting to note that after this step, the Studio automatically creates a variable with the same name and type. Next, we need to create and write the file, with name setted by variable, headers and body coming from the rendering. And finally, we'll call the move file activity to move file that came from start to process folder. One important detail, let's not forget to move the item even in case of an error. This logic can be placed in the catch block of the operation process. And with that, the operation level is also complete. Now, in our main process, we can finally get rid of all those unnecessary palettes. We'll simply insert a call to the person's operation process, passing the file information and its content we retrieved as input. Much cleaner, right? Let's do a quick test to make sure everything's working correctly. We'll drop in some files, including one with invalid data. You'll see that the execution flow will call the processes exactly as we set up in the operation level. The files will be correctly generated in people data age, and others moved as planned in processed error folders. I owe you one, so here's the list files activity. This activity lets us list files, directories, or both by simply providing a specific path, which can even be dynamic. By setting recursive to true, it'll also search through subdirectories. In our example, we want to list all files in the people data, processed, and error folders. Next, we'll insert a mapper referencing a simple string and group it within an iterate block. This will loop through all the file information provided by the list files activities output. Inside the mapper, we'll add a variable to indicate the current folder, but without the absolute path. The substring after last function is perfect for this. It lets us extract the string after the last pattern, in our case, the slash, from the location. If the folder is the main one, we'll replace it with not processed. In the final string, we'll concatenate the variable with the file name. Finally, we'll select the mapper as the accumulate for the group and log the output. Create a main process with timer that start the execution flow and invo the process for list files. Let's do a test. I've placed files in all the folders to verify its functionality. The document generated shows all the file in folder people data and in all its subdirectories. For your ultimate challenge, I'm leaving you with a super interesting task. Schedule a process that regularly scours your error and process directories, find and delete any files older than 5 days. Here are a few quick tips to get you started. You'll want to grab the date and time from the file itself and convert it to a date-time type using the parse datetime function. From there, a simple comparison operator will help you figure out the file's age, and for the actual deletion, the remove file activity is exactly what you'll need. I really hope this lesson has empowered you to level up your code organization in TIBCO BusinessWorks. If anything's unclear or you just want to chat about it, drop a comment below. See you next time.